Hello sir, myself Madmohan. I am from Triple department. Today my topic is generation of over voltages and causes. The first one, introduction to over voltages. Over voltages are voltage levels that exceed the normal operating voltage of a power system. They can cause damage to electrical equipment and reduce system reliability. Understanding their causes is essential for designing protective measures. Causes of over voltages. There are two causes, internal and external causes. In internal causes, switching surges, insulation failure, arcing ground, resonance. External causes, lightning. Internal and external causes do not produce surge of large magnitude, hardly increase system voltage to twice the normal value. Generally taken care by providing proper insulation to the equipment. But surges due to lightning are very severe and may increase the system voltage several times the normal value. Types of over voltages. Over voltages are generally classified into temporary, sustained and switching over voltages. Temporary over voltages occur briefly and are usually caused by switching operations or faults. Sustained over voltages persist over longer periods and can result from system conditions or faults. The next one, over voltages due to switching operation. Switching operations such as circuit breaker, closures or load switching can cause transient over voltages. These over voltages are typically short-lived but can be severe enough to damage equipment. Proper switching procedures and control devices help mitigate these transient effects. The next one, over voltages caused by lightning. Lightning strikes induce high voltage surges in power lines leading to over voltages. These surges can be very rapid and intense, often damaging insulation and equipment. Protective devices like lightning arresters are used to divert these surges safely. Over voltages from system faults. Faults such as short circuits can cause sudden increases in voltage levels. Fault clearing times and system configuration influence and magnitude of these over voltages. Proper system design and protective relays help limit the impact of fault induced over voltages. The next one, over voltage during load rejection. Rapid load rejection can cause voltage surges due to sudden changes in system conditions. This phenomena occurs because of the system's inability to adjust instantaneously to load changes. Voltage regulators and control devices are used to stabilize voltage during such events. The next one, resonance induced over voltages. Electrical resonance in transmission lines or equipment can amplify voltages significantly. Resonance occurs when system capacitance and inductance interact at certain frequencies. Proper system tuning and damping measures prevent harmful resonance conditions. The next one is causes of over voltages in renewable energy systems. Intermittent sources like wind and solar can cause fluctuations leading to over voltages, variations in generation output and grid connections issues contribute to these over voltages. Power electronic devices and voltage control systems help manage these fluctuations. The next one, protective measures against over voltages. Surge arresters and lightning protectors are primary devices to safeguard against over voltages. Proper grounding, shielding, and system design reduce the risk of voltage surges. Regular maintenance and system monitoring help detect and mitigate over voltage conditions. The next one, conclusion and summary. Over voltages can arise from various causes, including switching, lightning, faults, and system resonance. Recognizing these causes is critical for implementing effective protective strategies. Continued research and technology improvements are essential for ensuring system stability and safety. Thank you.